Hey guys, I hope everyone are doing great there. So I'm Archana. I'm of Sri Venkateshwara College of Engineering, passing my graduation in 7th sem of EC domain. So today I'm going to discuss the topic of real-time system development methodology under real-time system and with the subject code of 18EC731. As I already explained what is meant by real-time system in my previous video, so you just go through those videos under the playlist of real-time system. So today I'm going to discuss about what is meant by real-time system development methodology. So here we can underline the word that is development methodology, as we know that the methodology is nothing but the flow chart or a plan or a framework where it will be including what need to be planned and what need to be executed by a real-time system. So it is nothing but the methodology which will be used for any framework or like before implementing the real-time system, the methodology plays a very important role. So in the methodology, it can be a framework or it can be a paper plan or anything. So it is nothing but it is a pre-plan where for before it is before any implementing any real-time system, the pre-plan is need to be like, or the framework need to be designed here, and whatever the inputs and whatever the outputs and whatever the interrupt need to be given for any of the system, it should be planned here. And it is nothing but a flow chart, and before after the what is the flow chart has been prepared, and after the accuracy of this system can be expected, as we can assume that after the complete implementation of this system, we can expect some accuracy or efficiency from the system. Then only the system may runs in an accurate way as well as in a very predefined way. So here the methodology or the development of this methodology plays a very important role here. So the methodology is nothing but the framework or the development of a framework before the implementation of any real-time system. So let's move on with in a deep way, or in a, I will just explain in a brief manner with giving in some few examples of a real-time system explanation as well, and also we'll just see some overview of that explanation or example of that. So what is meant by real-time system development methodologies? Or it is nothing but it is an approach or frameworks that guides the process of designing and implementing real-time system. As I already told, it is the process, like as we can see in the flow chart, we will just define few functions, and afterwards we will just like go through a few conditions. If the condition satisfies, then it will execute something. So here also the same thing will be happening here. First we will design what need to be like what are the tasks that need to be executed, or what are the tasks that need to be performed here, so that the output will be in a very good manner, or it will be in a efficient way. So first we'll design the system, and then after the designing, and if the design is okay, and then we'll be just looking after the implementation. So implementation of the real-time system can be what is that, it can be fulfilled by the methodologies, or what are the like what are the frameworks that will be prepared here. So the framework is a very important plan, or framework is a very important thing that need to be what is that that need to be first pre-planned, and first it need to be predefined, and then only the implementation of the real-time system can be done. And here in the real-time system, as we know that the time, the task that need to be that need to be completed before the given time, or before the specific time. So here the time plays a very important role, that too in the real-time system. And I can give some explanation of two real-time system development methodologies, and those are first I'm taking about the waterfall model with modifications for real-time system. So it will be waterfall model with modifications of for real-time system. As we can, so we can see that the waterfall model overview, and also what are the modifications that can be done for real-time system, we will be just discussing here. So what is actually meant by over like waterfall model overview is nothing but the waterfall model is a traditional software development methodology that progresses through distinct phases such as requirements design, implementation, testing, and maintenance. Real-time systems, however, often require modification to meet their specific needs. So what are the modifications for real-time systems are? Requirement analysis. In real-time system, a key focus is on defining and analyzing time requirements. This includes specifying the maximum allowable response time for critical tasks and determining the overall system timing constraints. And coming to the design part, the design phase incorporates scheduling and the design phase incorporates scheduling and resource allocation consideration. Real-time scheduling algorithms are applied to ensure that tasks meet their deadlines. Hardware choices such as the selection of the process and communication channel are critical to meeting timing constraints. And the next one is implementation. So after the design as well as what are the requirement analysis has been made, then we will go to the implementation of the real-time system. During implementation, developers need to pay special attention to timing issues. As I already told, real-time system is very crucial on timing. Real-time systems often involve low-level programming to control the precise timing of operations. And next, after the complete implementation and design, the last or the final part will be the testing. Real-time system require throughout testing to validate that they meet the specified timing requirements. This may involve both functional testing and performance testing under various conditions. And here we can see the general view of waterfall model. As we can see that the requirement gathering and analysis, as I already wrote, the requirement analysis, like whatever the things that need to be given as an input, then we will be just giving with this block, as it is shows the requirement gathering and analysis. We'll just put together and we'll just give it to the system design. Then it comes to the designing part. So here we can see that the waterfall model, so step by step it is been implemented and also it is been tested and developed here. So first will be of requirement gathering and analysis, and coming to the second one will be of system design, and then the system design, after the design of this waterfall model, then it will be given for the implementation. So in the implementation it will again recheck whatever the design is been given, and then it will just start to okay, the conditions will be satisfied, and if it is not, then it will be again re-given and then re-executed here. So once it is been satisfied, then it will be given for the testing. Here the testing will do nothing but, like, it can be a software testing or it can be a hardware testing. Software testing is nothing but it will be just like testing the programming languages. If there are any bug, then any error, then it will be just debugging. And if coming to the hardware performance, we will be just seeing or like what are the hardware performance is been like going in a smooth manner. And then after this testing as well, deployment of the system, like nothing but it will be, it is a plant. Deployment is nothing but will be in the real-time system, it will be just known as a plant. So plant is nothing but the real-time system after the complete what are the implementation, design and testing. If all this process has been executed and it is been enhanced, then on the deployment, like we will be just placing the real-time system in the generation. And then coming to the maintenance, after the deployment of the system, we will be just maintain like there will be few conditions to maintain and a few things that need to be maintaining in a proper way. So here the maintenance comes here. And the second example I'm going to explain here is V model for real-time system. So we'll just look after the overview of this real-time system. The V model is an extension of traditional waterfall model, emphasizing the relationship between each development stage and its corresponding testing phase. In the context of real-time system, the V model is adapted to incorporate real-time considerations. And coming to the next point is of verification and validation in parallel. The V model for real-time system places a strong emphasis on the concurrent verification and validation activities. This means that as each development stage progresses, the corresponding testing activities are carried out in parallel. And the early integration testing. Integration testing, particularly in the context of real-time system, is conducted early in the development process. This ensures that the interaction between the different system components, especially those related to timing and synchronization, are thoroughly tested. Coming to the timing analysis, the V model of real-time system is incorporated detailed timing analysis throughout the development life cycle. This includes analyzing worst case execution time. So here the worst case execution is nothing but the time analysis need to be followed very in a very precise way and also in very concentrating manner. So this includes analyzing worst case execution times, response times and overall system timing behavior at each stage of development. So here the time is very important role. And coming to the last one is nothing but incremental development. The V model for real-time system often encourages an incremental development approach, allowing for the early identification and resolution of timing issues as the system evolves. We can see the block diagram over here for the V model. So here user requirement models is been given to the system requirements models. So whatever the user is nothing but we the people who, like, what are the requirements we need to be have, like what are the requirements we are having, we'll be just giving in this block, and then it will be the like user requirements is being given to the system requirements, like it will be given as an input for the system. And then after the system requirements, whatever the inputs we have been given from the user, it will be taking and it will be filtering out, and then it will be giving input for an architectural models, or it will be of design, and then component design models, and then at the last unit design model. Then the unit design model is been given for units, and then the units will be given for the components, and components are subsystem and integrated system and operational system. So here the OS, the operational system, is been given where it is a real-time system. So what what is SW, HW, and data? So software, hardware, and data. So same thing will be even here also, and subsystem, integrated systems, and operational system. So this is the overall V diagram general model, sorry, general diagram. Thank you for watching my channel as well as my videos. Please go through with all my videos and keep learning where it may helpful for your placements as well as for your exams as well. So keep learning and make your friends to learn. Thank you.